There's much more people than I thought there would be, which is nice. So the talk is called Setting Up Your Own Testbed. And well, the learning goals for this session is basically that after the session you will hopefully know how to set up your own desktop testbed. So let's say if you have something like, I don't know, 5 to 10 nodes that you use at your desk for local experimentation, you could use our software infrastructure to also program them, which allows you to use all the tool chain that we have developed in the WiseBed and the SmartSantander project. But you could also set up a lab test bed or maybe even an outdoor deployment using the infrastructure software that I'm talking about, which is the testbed runtime. So you also know some details about the testbed runtime project. You know where to find relevant documentation, and eventually you might even know how to federate testbeds or federate with the SmartSantander infrastructure. I will try to keep this a little bit short because it's really basic steps at the beginning, just for you to get an impression that it's nothing to be afraid of. It's very simple to set it up at the beginning, and if you want to know the very specific details, you can dive into the documentation which is available online, or you can contact me for the details. So a quick outline. First, I talk about testbed architectures in general, then the project, then we see it in action. That is, I will set up a testbed right here on my desk. How to install it on a normal server machine. And then I'm going to talk a little bit about configuration and some future features like extending it with plugins. Okay, testbed architecture. We have seen these slides before, so I will just briefly discuss. Again, for the context of the SmartSantander, you have seen so many slides with architecture pictures, pretty complex. Maybe you remember this one saying that we have one kind of the SmartSantander architecture devoted to node level experimentation or service level experimentation. This is the context in which we are currently what we are talking about. So again, you've also seen this slide showing the different planes of test beds. So there's a client plane where your client application runs, be it the WiseGUI, experimentation scripts, custom clients, the Timon application. And then you have the management plane, in which there are functionalities like flashing and resetting nodes. And you have the, let's say, experiment or data plane, basically where data exchange is happening between the client applications or whatever service you are writing and the sensor networks or the IoT devices in general. And this part of communication is both managed by the so-called testbed runtime project, which is a project implemented in Java, running on the Linux or whatever, Linux, Windows, Mac infrastructure, whatever you have at your lab or deployment. And it offers two different APIs, one being the SOAP API, which is the original API once upon a time specified by the WiseBed project, slightly updated nowadays, and then the REST API that we set up to enable things like the WiseGUI. Okay. Quick reminder, typical testbed architecture, you have a portal server, you have some gateway hosts. For example, in the Lübeck deployment, we had some netbooks back then. Nowadays, we would probably take Raspberry Pis. Back then, it was netbooks, which were much more cheap. Not cheaper, but Raspberry Pis were not available. And you have some kind of wired infrastructure, sensor nodes being attached to USB hubs or not attached to the gateway host. But for example, in the SmartSantander deployment or in the Santander deployment, that architecture might look a little bit different. For example, gateways might be attached using some form of wireless connection, Wi-Fi, GPRS, whatever. Sensor nodes might not always be attached via USB connections, but also might be attached wirelessly, meaning If you have to reprogram them, you have to do it over the air. So this kind of stuff is also supported by the architecture. Now the project itself, testbed runtime, is, well, it started off as the reference implementation of the WiseBed APIs, me being the main developer of the project, and also one of the designers of the APIs back then, together with Dennis Pfisterer and other people from WiseBed. We did a lot of work there. It has seen something like 20 releases in the last 3 years, some of them bug fix releases, some of them feature releases. During the WiseBed project, we had 9 different sites, each having testbed deployments, most of them indoors, and 5 of the sites out of 9 were running the testbed runtime software, or some of them still are running the testbed runtime software. Others basically already had some kind of software infrastructure to rely upon, and they just implemented some kind of wrapper for the APIs to make their testbeds available under these APIs. So, as I said before in my last presentation, everything is open source. The fact that I like to emphasize. Okay, so you can find the source code under the repository of the ITM, which is the Institute of Telematics, where I'm working, /testbed-runtime. You can also find the documentation there. You can find the issue tracker. So you can see what's the implementation status. If you have some issues with the testbed, you can open issues. And so this is, I really try to run this project as other open source projects are run, and I hope for like lots of interaction with users and communities. There's also mailing list, still located at wisebed.eu. Testbed runtime users being more targeted at the infrastructure providers, so the guys that actually have the lab deployments, and the others are being targeted at the actual users. Okay, so the last release that we've made was the version 0.8.5 about a year ago. Has been in production use in Santander deployment and Lübeck and Guildford since then. Today I would like to present the version 0.9 beta, alpha. We'll have to see how well it goes. Soon to be released. That is, since in the last year I have basically also not only me, but also with help of some friends, colleagues from the Institute and other institutions, made a complete rewrite with lots of improvements, especially many simplifications, because the old version was basically working but kind of hard to install and configure. I went to great lengths to simplify the whole system. Higher performance, cleaner design, better extensibility, and so on and so forth. And also very neat to have is that the REST API is now embedded. It used to be some kind of wrapper around the SOAP APIs, which just made it slower and so on. But also we have the front end, the WiseGUI also embedded. Okay, enough said about the frame around it. I want you to see testbed runtime in action now. Basically, we have 2 different types of processes running. One is running at the portal server and one is running at the gateway. And now you will just have to, let's say, imagine that I brought here a server machine and a gateway machine, a Raspberry Pi, to which I will attach nodes. I would just start both processes on my laptop right now. So let's first change to the directory in which I have it. So can you see this? I think you should be able to see it nicely. It's hard to see the commands. Just give me a second. So what I've prepared is on a USB stick, so in case any one of you wants to have that software version, you can just get it from my stick. So we have 2 jar files which reside in the jar directory, and you can just start them by invoking java-jar, and then the name of the jar file. And we have one for the portal server, one for the gateway, and then you pass a number of arguments, which is now not very nicely visible, unfortunately. Okay. You pass a configuration file, and in order to see something, we just set the lock level to trace. Oh. And it seems it's already running in a different tab. So okay, let's try it again. Start the process. And now the portal server is running. See a lot of printouts. If I switch to my browser and I open the web page, I will probably see the Wise GUI presenting. This is just started running from the process that I just started. Now, what I will do next, obviously, these devices need some kind of configuration. So I have brought these sensor nodes from the iSense manufacturer, and they need to be configured, so we get something that is called device DB for device database. So I will briefly have to add them to the database. Okay. So they will get a URN corresponding to their MAC address. Let's just add 2 or 3 of them. As you can see, there are more configuration options. I will just leave them out for now to keep it simple. Okay. Now if we switch back to the Wise GUI, we go onto the testbed site. You can see, if you click on the Nodes tab, that here are the nodes that I've just configured, and if I now go back to the shell and start a second process, that is the process for the gateway host, the gateway process will connect to these devices. So I go and start the gateway server, also give him a log level trace and the configuration file. Okay, that's it. Should be running. Now I'm going to attach the nodes while I'm talking. And as you can see, they are becoming available immediately. At least one of them. Maybe I should use another one of the ones that I configured. Okay. So the gateway process detects the devices, and you can immediately start to work with them using the Wise GUI or the other tools that I presented earlier this afternoon. Okay. Now we could do all the other stuff, make reservations, start to flash the nodes, you know, all the things that you have been presented this afternoon. And that's basically, well, how to set up your own testbed. Again. Okay. So you can see it's pretty easy. One thing I omitted is the configuration files. It's not so important now what's written in there. You can just see like the 2 configuration files that I passed are really short. Basically configuring how the internals of the architecture are to be set up. And like this is the one for the portal, this is the one for the gateway. I think best is, if you are actually interested in setting it up, you will just go to the website, browse the documentation on how to configure it, look at the individual properties, and basically be done in, depending on your deployment, in 5 minutes to 1 hour, or hopefully less, hopefully not much more. Okay. Even easier, for installation, there's a Debian package. So if you want to install it on your infrastructure, you can just go add our Debian repository at our institute to your sources list and Debian, and then install the solution using aptitude, apt-get. Then you go through the same process of editing config files and starting the testbed using init scripts. So pretty basic. So in order to understand what needs to be configured, I just want to give you a very rough run through the APIs, okay? Because there's different modules working together, or different services working together inside the testbed runtime. And now this is like going back in time a little bit. The widespread approach to testbeds was that we first wanted to standardize some kind of API to be able to wrap existing testbeds, make our own implementations, which was kind of different to the approaches that other testbeds have been taken at the time. So we had seen other testbeds that basically provided a web interface where you could upload an image, and after the image was executed you could download the outputs, and there was not much more interaction possible. So we said we start from scratch with an API, so you could basically allow all kinds of client applications to rely on that API. We have seen today several client applications like Timon, VoiceGui, experimentation scripts and whatsoever that actually do that kind of stuff. I have seen in the field lots of custom clients that have been used for experiments, demonstrations and whatsoever, all directly invoking the API, which was really nice. And well, basically API consists of some endpoints. We define the API in SOAP. So there is a reservation system which obviously allows you to create, query and delete reservations. We have the so-called SNAA API, the Sensor Network Authentication and Authorization API, which does what the name suggests, authorizes and authenticates. We have a so-called Session Management API, which is basically your first point of contact. So if you connect to a testbed, you will go to the session management and say, look, I have this reservation that I made with the reservation system. Please give me access to my experiment. Then the session management will give you a link to an endpoint of the wireless sensor network API, where you can invoke functions like flash, reset, send, and so on and so forth. And what you can also would have to do in order to get back data, which has nowadays been simplified, is you need to run a web server endpoint yourself at the client, and then you will tell the WSN API, look, here's my client endpoint, please send all the output to this endpoint. Okay. So, and then if you look at the API interactions, basically following that experimentation lifecycle that we've seen today also. First step, you authenticate with the SNAA, then you reserve the nodes. When you've done that, you go to session management, get a handle to the WSN, API which has a hidden URL, and then you can just run your experiment. Now, just for you, these are basically the building blocks, and the internal architecture of testbed runtime has somehow been centered around these APIs. Now, for the current version, we used to have separate software implementations for all the several APIs. Now, for the version that I presented today, I embedded all the stuff into one process because it's much more simple. Like back in the old times, you had to set up one SNA server, one reservation system server, one IWSN server, and so on and so forth. And now you just have the portal process and the gateway process, and that's it. So, still, you have to provide these APIs, and for that, you have to configure them, how to run them, and now, as I said, everything is embedded in one process. So you have the portal process, you have the gateway processes running on the different hardware architecture, hardware that has been deployed, and then nowadays the testbed runtime itself is realized as modules, individual modules. Some of them offering a service like the RS service, others being internal services. Okay, that's the building blocks. It's not very important what these individual services now are. Say, like, you can see that in documentation if you're on it. But the idea basically is that every of these modules knows a set of configuration parameters, and you can just, if you start the process, you can just pass the argument -- help config, and you will get a sample configuration with documentation, what all the property values mean. So you need to set some configuration for every module. And just to give you an overview over the most important things is, depending on where you want to deploy testbed runtime. For example, if I deploy it on my desktop testbed, I might not be interested in really authenticating users or having to sign up for my testbed. That's why, for example, we have an implementation of the SNA API always returning true. We also have one implementation that uses the Java authentication and authorization service. So you can, for example, use htpasswd files, given that you have a user database which is stored in htpasswd. You can use your LDAP system, whatever. In Weisbed, we had installed a single sign-on system called Shibboleth, which is kind of project specific because we used a slightly modified version. And so there's one backend for Shibboleth. Then we have one which also does a lot of authorization, which will be soon in place in the Santander deployment. It's called Shiro. It's based on the Apache Shiro Java security framework. So you can use all these different kinds of, depending on your deployment scenario, you can use different types of backends for the authentication and authorization. Also, we have different backends for the reservation system. One is being in memory. That's what I was just using here, like the in memory. If you restart the process, everything will be forgotten, obviously. We have one backend that uses the Google Calendar, which is very convenient, which is running in Santander, I guess, currently, and also in Lübeck. So you can always go to the Google Calendar and see all the reservations of the nodes if you're having access to the Google Calendar. So this is like the persistence layer of the reservation system being put in Google Calendar. We have one that uses the Java persistence API, basically allowing you to use it with all types of relational databases, and another special corner case. Okay, there are some more module options, and as I said, just go to the wiki of the testbed runtime project. As the current version that I just presented is still in work, it's not yet fully done. Hopefully it will be fully done anytime soon, but the most basic stuff is already in place. So you can go to the web page, you can check out the source, build it yourself. It's based on Maven. It's really easy to build. Just check it out with Git, clone it, invoke Maven, and then you should be ready to use it. And the documentation is at the wiki. One interesting thing might be for the future, it's a new feature not really explored yet, the possibility to extend the testbed runtime with plugins. I think it's very mighty. So over the years I've seen many feature requests to do this and to do that, and I could okay, having limited time, I could most of the time only tell people to, okay, it would be nice if you just do it yourself, use the source code, please help yourself and try to get it running. And then it could actually, it was a huge barrier for people to start implementing new features based on a bigger code base of the project. So what I did now for the new version is to specify a plugin API, which is basically giving plugins access to all the internal and external services that run inside the process, and it's pretty easy to implement them. For example, some plugins, one plugin might record the node outputs, store them in a database, expose an additional web service for users to download all the recordings afterwards. Another plugin, which is already implemented, automatically flashes unreserved nodes with a specified default image. For example, this can be used for Timon. Actually, it was a request from the guys at Guildford asking me if I could make that feature for them. What they do is they assess the communication channel by measuring the link qualities, and they always want to do it whenever there is no reservation running on the current nodes. Then the nodes will be flashed with the default image. And other kinds of stuff, you could also, and that's very important, write plugins for the gateways. So if you have device types that are currently not supported by the testbed runtime, you can, I guess, easily implement new drivers for currently unsupported device types. We just have to implement a certain interface, write that plugin as a OSGI bundle. So that's, well, to some of you might know OSGI. I will not go into details here, but basically this is a programming standard in Java that allows to write code that can be installed at runtime into a running Java process and removed from the runtime while the system is running, or can be updated at runtime. So you can write your plugin following OSGI standards, implementing special interfaces inside testbed runtime, and then install these plugins just by copying it into a special runtime plugin directory. Okay. The last thing I want to present is the idea of federation. We are currently working hard to finally make the federation for the several sites of SmartSantander project. Should be hopefully available soon. So the idea that we had for federation back in the WiseBed project, and we're still hanging to that idea, we still want to realize it in the same way, is basically the APIs that we designed, they are, let's say, federatable by design. So we designed them carefully in a manner that would basically allow us to take one testbed A, another testbed B, and another process called federator, exposing the same set of APIs, the identical set of APIs, and just federating these two testbeds. And now the client which would normally directly connect to one of the testbeds, can even just connect to the federator and have all the resources of the 2 or 3 or 5 or n testbeds available, just talking to one endpoint using the same APIs. Okay? That was the concept. You can even extend that concept. So you have maybe one testbed here, another testbed there. You could even expose some simulator using the SOAP APIs from the project. Then you could federate these testbeds using the federator component. Okay, so that's basically what we could do, or we are doing, can do in SmartSantander. We expose our federation using one federator process. Then, let's say you might have your own lab testbed and you would like to use your testbed together with our federation. You could just install another federator that federates the federator of us with your own stuff. That way you could compose federation. And also here, not too many details. For now, federator is also easily to implement, to install. You just can also install it using apt-get. There's also a Debian package. It works the same way, same manner of configuration. You can download it from the Maven repository, and you can look at the configuration objects in the same way. And it's also part of the testbed runtime project, the federator. So all the documentation and source code, more source code than documentation actually. But if you have any questions, please contact me. Whatever channel you like. I guess I'm available on all channels except Facebook. So I'm happy to be contacted by you guys in case you have any questions. Okay, I think basically this is my last slide. If there are any questions, I would merrily answer them now. Or in 10 minutes at the beer, maybe also would be nice. Okay, thank you.